Jim Manico is the VP of Security Architecture for White Hat Security. Everyone, welcome Jim Manico.
I think we all know by now that the threatscape of information security has changed radically. Every company you see on this slide has been hacked within the last 18 months, specifically through their web application. Not trying to shame those companies. No one is unscathed in the current threatscape. Verizon told us 53% of all successful attacks in the last 18 months or so were how? What main attack vector is the majority of breaches today? SQL injection, no question about it. So this presentation is not an advanced, brand new presentation with new material. I'm going to blast through relatively quickly all of the core controls that a developer needs to build a secure web application. And this is kind of like a review. This presentation is an open presentation. My goal is to encourage you as a security professional to pass the word. There are still about 17 million developers that we need to influence to write secure code, and let's get started. So SQL injection, advanced persistent threat, no way. These two characters are enough to take down a website. You have an update statement, single quote, semicolon gets injected in, and suddenly the entire table gets wiped out. It's like this is not a complicated attack vector for even a modest threat agent. You have tools like SQL map, point, click, own. And so we have got to take this threat seriously. And there are so many different ways people talk about mitigating SQL injection. And I see a lot of people spreading false information because the truth is you really want to stop SQL injection. If your goal is to stop 100% of SQL injection, not maybe stop it, not possibly stop it. If you want to absolutely stop this threat, you have one choice and only one choice, and that is query parameterization and variable binding, and it's available in every language on the web. Here we see it in PHP. The hallmarks of a query parameterization API are placeholders in the query and the binding of the variables into the query. Underneath the hood of this language is some kind of driver that will do the contextual output encoding needed to escape data so it doesn't jump out of the current context it's in. So without the theory of what's happening underneath the hood, again, this is the only technique that we know of that's going to stop 100% of all injections. It's available in .NET. We have untrusted data coming from open text boxes being bound into placeholders in the query. Underneath the hood of .NET, the encoding happens in the right context. This threat goes away. It's available in Java. It's been available in Java for a long time. Prepared statement class, you have your placeholders. We're binding untrusted data into the query, and this problem goes away. Now, I saw a quiz question from a web security certification, and they said, if you use the prepared statement class, you are now immune to SQL injection. True or false? The answer is false. That's not true. It's a combination, because you can take a string concatenated query, you can ram it into the prepared statement and still be injectable. We need both techniques. We need the parameterization API, we need the variable binding. It's also available for the Hibernate query language as well. For instance, Hibernate is a very common object relational mapping engine. If you're a developer, if you're a Java developer, it's something that's most likely in your world if you're doing high performance computing. Here we have an object query. We have a placeholder for the employee ID. We bind the untrusted ID in. Injection goes away. It's available in Ruby. Ruby is the only example of it in the history of programming language where someone provided an API that was to parameterize queries, and it actually caused injection. This is a specific example right here, where underneath the hood of older versions of Ruby on Rails, they actually use string concatenation under this parameterization API that caused injection. Again, it's the only time in a language I've seen a parameterization API cause harm. And this was fixed in Ruby 3.2.4, 3.1.5, and 3.0.1.3. So it was a framework issue. And I've even gone back with other researchers and pulled down database drivers from 10 years ago, and they were not injectable from at least our testing. And Ruby's the one example of that mistake. Sorry for you Ruby fans. Cold Fusion. Oh, man. Anyone slinging some Cold Fusion? Well, this kind of makes me shudder a little bit. But even Cold Fusion has query parameterization. It's actually one of the best parameterization APIs. It lets you parameterize even table names And that becomes really important when you're doing things like sharding and other high-performance computing, multi-tenant type of issues. So we have cold fusion that's even parameterizable. Oh yeah, Perl. Who's slinging the Perl? Go ahead, it's okay. Slinging the Perl. I'm proud to be slinging the Perl. Yeah, one. Thank you for that. Even Perl has a SQL injection resistant parameterization API, simple to use, rock and roll, injection goes away. Look, folks, this threat is so important, and how are we doing as an industry in stopping SQL injection? What do you think? Survey says? I think pretty poorly. We see these events on a pretty daily basis. So my goal is to get you to take the OWASP query parameterization cheat sheet, some of this slide deck if you want, and pass the word. I challenge you all this year to teach at least everyone in this room. We're going to do a pact. I want all of you to teach at least 100 developers about query parameterization in 2013. Anybody with me? Anybody? 100 developers? Oh, come on, I see like 10%. Everyone, come on, join 100 developers. Anyone with me? Thank you. That's our mission. Let's spread the word. Query parameterization, SQL injection is causing so much radical harm. We still have about 15 million developers to influence. Those of you who raised your hand, you're awesome. Those of you who didn't, come on. So there's hope. In the future, we're going to see frameworks auto-protect against SQL injection. And a lot of people don't agree with me on this, but I think that's the only real hope that we have of influencing, again, millions of developers to build secure software. And not every security need can be put into a framework. Not every security need can be taken away from a developer, but there are certain categories that can. And I really think that SQL injection can go away if we use more frameworks like the link system in .NET. What this is it's an object relational data connection API. It's fairly common for .NET developers. And the developer just builds his classes, maps the database, and runs the query. This is an object query in .NET link system, and there's no parameterization here. They're just using an API that underneath the hood rips out all the untrusted data, rips out every variable, and auto-parameterizes. So there's hope, folks, that we'll have frameworks that automatically protect against SQL injection without the developer having to do anything special. You just use this proper API, and this problem goes away. So this isn't in super widespread use. It's in reasonable widespread use, but it's an example, again, of an API that developer, if they just use it, just use this piece of the framework, SQL injection completely goes away. There's hope. There's a cheat sheet out there which has an example of how to do query parameterization in pretty much every language we can come up with. That's the OWASP query parameterization cheat sheet. I ask you please to pass the word. Now, this is a really debatable topic, how to store a password securely. I highly recommend, if you care about password storage, it's a very difficult and contentious topic. John Stevens is giving a talk at 1 o'clock where he talks about a next generation password storage mechanism, where he's talking about a threat model and how to store a password securely. So I highly recommend you go to that talk. That's next generation password storage. This is kind of the state of the industry today. We have 3 major techniques we need to do in order to store a password in a relatively secure way with today's crypto theory. We want to make it one way. We want to make password storage so it's only verifiable but not reversible. Even if you're an administrator with DBA access, you should not be able to uncover your users' passwords in any reasonable amount of time, even with supercomputing resources. So we want to make it one way. We want to take it out of dictionary, rainbow table space. We're going to use a cryptographic salt. So we're not just hashing a 10-digit password. We're putting like a 64-character string before the password that's random, and then we hash it. That makes attacks like, MD5. Go look at md5crack.com. They have several billion resolved hashes available for free on the net. And you know what advanced rainbow table I tend to use if I'm doing research? I use Google. Most MD5 hashes that I throw into Google resolve right away. So using just a hashing algorithm by itself is a horrifically bad idea. We want to do a one-way algorithm. We also want to do salting. That's just putting a random value per user before the password, before we hash. And then a technique called key stretching. We want to purposely slow the algorithm way down. We want to slow the algorithm down. And we do that by, once we take the password, put the random salt before it, then we call the hash, we rehash again and again and again, in my 60, 70, 80,000 times if you're using a fast algorithm like SHA. And so this is a chunk of code from ISAPI, written by primarily Jeff Williams and a few others, and I'm part of the project as well back in the day. And this is how I kind of prefer to store a password. I rather write my own code so I have more granular control over the pieces of this algorithm. And a lot of people disagree, that's okay. We'll talk about standard algorithms as well. We take the password, a random salt from the user, and a work factor, key stretching factor, the iteration count. I then start my hashing algorithm, reset, I take 32 characters, random characters from a configuration file. It's a random string for the entire system. Then a random salt just from the individual user, off the user table that I generated when they first registered. Then the password, and then a hash. So it's a system-wide salt, per user random salt, password, then hash. Then I repeat that hash over and over and over again. And if you really want to defeat even like the nation-state level threat agents by doing a hashing of the same hash, that's usually bad form. There are techniques called hash chaining. As they're building rainbow tables, they're now doing it in both directions. So even the repeated hashing is being caught through some dictionary rainbow-ish kind of attacks. So instead of this, I recommend this. So at the time of rehashing, throw your salts back in, take the hash of the current iteration, throw your bytes back in, and just replay this algorithm at login time, and you're good to go. And how slow do you make it? I make it slow based on the current hardware I'm using. If I want this algorithm to take like half a second to a second per one full verification pass, and that's usually slow enough. Because the reason why salting is not enough is because for $5 grand you can make your own supercomputer at home and do like a billion plus crack attempts against this per second by getting like a $1,000 computer, 4 Radon video cards, make a GPU cracker at home, leveraging cloud services. Now even your average threat agent, your average hacker, can get himself mammoth supercomputing resources on the cheap because of modern computing. And so even if the attacker gets a copy of your salt, the whole purpose of good password storage is even someone who sees the salt, sees the hash, should not be able to reverse the mechanism. But as the attacker, if I get your salt, if I'm a DBA and I'm an evil DBA and I have your salt, I can go make my own custom rainbow table specific for your account in a relatively reasonable amount of time. And the thing is, if I'm really trying to take you down, I'll use massive parallelization. This is not a linear problem. I can spread this problem over 1,000 different computers, and if I have enough money, I can crack it right away. If I'm willing to really spend money and fire up a couple 100,000 Amazon AWS instances, I'll just crack it faster. So it's just money that's slowing me down, not necessarily computing power these days. So not only do we salt, but we slow it down. We slow it way down. And so if you don't want to build it yourself, I'm okay with that. There's 2 algorithms that are slow enough and have enough of these characteristics that it's at least a reasonable choice for password storage. There's bcrypt or scrypt. It's really slow on purpose. It's derived from Blowfish, so some organizations that have NIST standard requirements can't use this, but that's fine. And this is also potential denial of service. It takes about 10 bcrypt rounds that run at the same time to pin even a high-performance CPU. But the issue is, though, denial of service attacks are real noisy. Password storage attacks, you're on Pastebin, you're in the Wall Street Journal, and it's a pretty damaging event to your organization. Also, there's PBKDF2. This is a password-based key derivation function. This really wasn't made for password storage, but it has the proper characteristics that we're looking for. And so I see PBKDF2 for SHA-3 available now. These are reasonable choices for password storage. So password storage. Next, cross-site scripting, another relatively easy attack. Here we have a simple cross-site scripting session theft attack. We're grabbing the cookie from the current site, adding it to a URL, and redirecting the user. Just to want to explain the basic concept. Here we have a simple site-defacement attack. We may be on a chat board together. I post the script to the chat board. You then look at my message a day or a minute later, and this script executes. It's a complete compromise of the client. I kind of see cross-site scripting as like the cockroach of the internet because it pops up so much. You stamp one out, another one pops up. Most languages do not have a good library built in to help stop this threat. So it's still a problem that pops up on a very, very regular basis. And the kind of things we can do with cross-site scripting is off the chart. We can steal your session. We can deface the site from the context of an individual user who's a victim of that attack. We can undermine any cross-site request forgery defense just about. We can redirect. You can set up keystroke loggers through cross-site scripting that are effective. We have got to take this stuff seriously. And by the way, these slides are open. I'm going to give you a copy. You don't have to take pictures. You can just chill. Give me a copy of all this. So, and this is why cross-site scripting is such a challenge. Based on the context of where untrusted data lands in an HTML document, you need to do something different. And so we debate this a lot. Do we tell developers just enough about stopping XSS so they can be effective and can get 90% or so of the different vectors successfully? Or do we tell developers about all of XSS defense and overwhelm them with this knowledge so they give up? It's not an easy debate. I'm going to tell you at least as much as I know about this risk, and you can make the call for yourself. If untrusted data lands in a body context, between two tags, between two table tags, this is a basic context within an HTML document, we want to do HTML entity encoding. And I'm going to use .NET as the API example. .NET by far. And I'm a Java guy. I'm Java 100% forever. But you got to admit, .NET has done a lot in terms of language security from a web security point of view, where they've integrated a lot of these controls into the language. And we need to see, Java's going to emulate this someday. .NET's ahead of the game, so I'm going to use .NET for now. So to stop this, I would wrap that untrusted data around anti-XSS dot encode for HTML. In this example here, this is an attribute within an HTML tag, within an HTML attribute value. I would say anti-XSS dot encode for HTML attribute. Within this context, we have untrusted data landing in a link that a developer is setting up for another user of the system. And this is just a standard encoder. This is URL encoded. This isn't even special to XSS. This is just part of the URI standard in terms of how to represent a URL with certain metadata characters. So in this case, I see this a lot in search features, where you search on a term, and that term then becomes linkable. And so here we would just do URL encoding around the untrusted data. And if you want to really go out of your way to stop XSS, you can also first you URL encode the untrusted data, and then you HTML attribute encode the entire URL to be very resistant in that context. Here we have a complete URL. Twitter got slammed by this through the Mikey worm, the goat-loving worm back in 2010, where one user submits a URL to Twitter as part of a tweet. Twitter then has to make that string, it's just a string at that point, make it linkable to other users. It's actually a pretty difficult use case. So first we get the tweet, and we walk through each and every word one at a time to check if it's a URL pattern. If it's a URL pattern, we have to make sure it's not a JavaScript URL. That's actually a legal URL that still pops in Chrome and IE to this day. So yes, it can't be a JavaScript URL, that's blacklisting. Whitelisting, it should be an HTTPS or HTTP URL only. We then want to check for malware when we first get the input, and then when we send it to a user on output as well on occasion. And then we want to do attribute encoding at the time of rendering the URL within that context. Kind of a tricky example. Cascading style sheet. Who here is still supporting IE 6 or 7? Oh, I'm so sorry. We should have a support group for you. Don't you agree? When I was a consultant building websites most of my career, I would make bids on projects, and I would say, look, if you want me to build it, blah, 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 it's going to cost this much. And if you want me to support IE 6 with all these features, you get the cost is double. And you know why I said that? Because that's how much time it took to support it. Yeah. So as a Sicilian, you would say, to IE. Sorry, it's a person. All right, back to it. So in this context, in .NET, we would say anti-XSS.encode for a cascading style sheet. to really be resistant to XSS here. Unless you're supporting IE 6 or 7, even if you encode, I can put an expression attack in and still pop in IE 6 or 7. So really, there's a rare need to support untrusted data driving style. So I think you're better off just not doing this kind of markup within your user interface. Now this is really common. This is untrusted data landing in a JavaScript variable assignment. We do this all the time. We need to in order to support advanced AJAX features. And it's not even advanced anymore. AJAX is kind of how we build web apps these days if you're building a new app. And so we have untrusted data landing in a quoted JavaScript variable context. This would be anti-XSS, encode for JavaScript. And we have to parse JSON properly as well. We kind of keep a lot of the original author of JSON, who's here, and I salute you, by the way, but the original documentation from him said to use the eval statement to parse JSON. And why is that a bad idea? What if you parse, so you hit a web page, you get the flat HTML, and then that page makes a JSON request to get the rest of the data, the dynamic data for that site. It comes back as JSON, then you get to parse it to populate the page. So why is using eval to parse that return JSON a bad idea? It's fast, but it will also it will execute any code that's in that JSON object. So we want to use JSON.parse, a formal non-executing parser, which is available in most modern browsers. Even jQuery is heavily vulnerable to cross-site scripting. This is the most popular framework for developers on the planet. This slide came from Dave Wickers, who's been doing research with other folks around the dangerous APIs in jQuery. But all of these core methods, really common methods that jQuery programmers use, if untrusted data lands in any of these, it will execute. It will either, in this context, it will execute as if you're in an event handler or in a script block. And these methods, it will just directly modify the DOM, modify HTML. So we have to be really careful about the use of jQuery. Chris Schmidt came up with his own encoder, a jQuery plugin. Now, even deep within JavaScript, we can encode untrusted data before we put it into an element dynamically and encode in that context as well. So this is just a real tricky problem. I'm going to jump ahead here. The hope for the future, I think, is content security policy. This is supported by a good chunk of browsers. And more importantly, it's becoming a W3C standard. It's not just a Mozilla idea. It's actually an anti-XSS standard that's going to be supported by all browsers. Everyone's agreed that this is a good idea. First, you must move all your JavaScript into external scripts. Who here is a JavaScript developer or does a lot of JavaScript coding? A small number of developers. So what do you think about inlining of JavaScript? I'm sorry, what do you think about externalizing all your JavaScript into separate JS files? What do you think of that practice? It's just the right thing to do. Not even for security. Why is there benefits to doing that? What do you get for that?
Modularity and just how much you think of things abstractly as opposed to like mirroring something on file.
Yeah, and also performance. When I hit your page first and all these JavaScript files come down, I can cache them so subsequent hits to that page are not going to reload that JavaScript every time, which is what happens when you inline it within your HTML. You're obviously just a good programmer to say that. That's just the right thing to do, so rock on. Now, when you do that, it also makes your application much easier to adapt content security policy. And again, Firefox has supported this for quite a while. IE10 preview release supports some of content security policy. Chrome already supports it through an experimental header. And the W3C is taking this seriously, so especially a year out, we're going to see a huge number of browsers support this in a fairly complete way. Just a couple quick examples. Again, content security policy works in that I make a request to your server, you return me in the response a chunk of HTML, and in that response back to the browser, you'll give me a header that enables content security policy, and now my browser, now that it's seen that this is a content security policy aware page, is going to stop the ability of that page to execute JavaScript that's in line. The only JavaScript that can execute is JavaScript that's been set by policy. Here's an example of an older version of one of these policies. This is from Brandon Stern, the original browser developer who implemented content security policy for Mozilla. So this is saying, let Once we get the main page of the site, that page can, by default can only make a request back up to that server for secondary objects, except for images, which can come from anywhere, except for this certain plugin data, which can come from these two servers only, and except for scripts, which can come from self, as well as scripts.example.com, which is a bad idea. Just giving you an example of how this works. Please don't trust JavaScript from third-party open sites. Bad idea. But that's how the policy structure works. Here's another example. Content security policy. This is saying the default source for JavaScript is coming from cdnexample.net. This is what you need to do when you're supporting a large content delivery network like Akamai or such. Frame source none, no, can't be framed. Object source none. No plugins will be enabled on this page as well. Other benefits for content security policy. I think as a developer, as a security architect, it's time to put this on your radar now. It's time to start experimenting with it. And if you are a corporation where you have full control of the browser your users are using for your intranet applications, and I know a lot of corps that do standardize on Firefox, man, you can use content security policy very effectively today. For consumer-centric sites where browsers, we have a lot of different browsers hitting your apps, it's going to take a year or two before we see truly mass adoption. But still, many major sites like the Twitters are using content security policy already. We see Chrome's add-on mechanism using content security policy within the browser for a whole secondary purpose. So it's here and something I want to put on your radar to start researching as a security architect. Cross-site request forgery. There's two major defenses I'm a fan of. There's crypto tokens. This is the synchronizer token pattern. To stop cross-site request forgery, when the user first logs in, generate a strong random value and put it in the session. Whenever we render a form or a URL is going to change state in some way, put that crypto token from the session into the form as a hidden variable or on the URL as a parameter. And every time you get a request that's a state-changing request, rip out that token, compare it to what's in the session, and if they are not equal, reject the request. We've known about this for years. This is called the synchronizer token pattern. But I'm also a huge fan of re-authentication. Even if you're vulnerable to XSS, because XSS can undermine the token pattern pretty easily. But even if you're vulnerable to XSS, re-authentication stops cross-site request forgery cold. Amazon does this really good. Here's an example of one of the rules. The moment, even if you've logged in and you're checking out, if you try to ship an item to an address that you've never shipped to before, Amazon thinks, hey, someone may have intercepted this in some way. You may have left your machine and someone sat down. So if you try to ship an item to an address you've never shipped to before, even after you've initially logged in, they're going to make you re-authenticate to verify that. That stops CSRF. It stops other passerby type attacks. I think it's a good control. It's not used enough. We see it for change password, but I think we can use this in other security-centric features. It's easy to implement. It's a very powerful control. Most users don't mind from usability studies we've seen from Amazon. We have a cheat sheet, OWASP, cross-site request forgery cheat sheet. It's one of the original cheat sheets in this series. Multi-factor authentication. Look, I'm going to give you one sentence and move on here. So, well, two sentences. Who here? Actually, I'm Jim. Many sentences. All right, give up. Who here is a World of Warcraft player? World of Warcraft? Come on, you can admit to it. Some of you are lying. World of Warcraft, past players, recovered players. All right, thank you, some of you, for being honest. I know many of you are not. It's all right. So how long has Blizzard had multi-factor for? Like 4.5 years now. And do they charge you for it? It's free service to protect your character. So here's my question. World of Warcraft players, if you're protecting your magic user who's throwing it with his fireball wand and his shoes of flying +3 and his magic scrolls with multi-factor authentication, you maybe want to protect your multi-billion-dollar financial organization with it as well. You with me? All right, I'm gonna move on. Let's talk about forgot password for a second. So forgot password needs to be at least as strong as your authentication layer, if not stronger. And even recently, I saw a site being developed. You hit forgot password, type in your email address and your username, and the password just shows up on the screen. Here you go, no problem. So I see this built weekly fairly often. best, I actually see some banks just, they just don't support it. You have to go through a calling process. You have to go through a calling process. So let's talk about some good ways that people have done forgot passwords in the past, or some of the more stronger development teams. They tend to use the pattern where you enter in your email and your username and a couple more bits of identity information, and they'll email you a link. And then you click on that link and you can reset your password. How secure is email as a transport mechanism? Security guys? Ryan, help me out. How secure is email as a transport mechanism for sensitive data?
Yes, I've been burned on that before.
It's
Purchasing things online and then getting a receipt that says, oh, here's your credit card info that was emailed to an AOL account. Thank you.
Exactly. So really, sending sensitive data, like a link that lets you fully reset the password to the account, I think that's a bad idea for security-centric websites. So I think we want to simulate multi-factor authentication. There's a cheat sheet, forgot password cheat sheet that talks about this in great detail. Number one, this is Dave Ferguson has wrote the first big white paper on this as banks began rolling to this mechanism. Number one, require identity questions up front. What's your username? What's your email address? What's your account number? What's your date of birth? There's questions on asking certain questions, but who cares? The more identity questions up front, the better. Then number two, ask a security question. Now we all know, as a control, security questions are not great. At best, they're good. So how do we find some good security questions to use? There's a website, goodsecurityquestions.com. Thank you for laughing at my joke. I attend anywhere it is. It's actually a really good site. It goes through, and they keep it up to date. It's a good discourse on how to choose security questions for your users. I prefer to choose security questions for them. I've seen users try to pick their own security questions, and they're the worst we can possibly come up with. So again, identity questions up front, ask a security question next, and then send them a token out of band. The best way to send them a token is through a separate factor token device. I won't mention any vendors. There are plenty of vendors who support this now. The next best thing is to use a mobile application, in my opinion, that has the authenticator on it. The third best way to do it is through SMS, and the worst way to do it is through email. But if you're sending a token over email, it is still stronger than sending a password reset link through email, in my opinion. So if the attacker has compromised your email account, they get the token, that's not going to let them reset your password. They need the identity questions answered and the security question answered to get through. Then we send them a token. Then we allow them to reset the password, and then they're in. And also email them to say, hey, your password just got changed as well. That tends to be a more secure way to leverage this feature. There's a really detailed cheat sheet, the forgot password cheat sheet, that talks about this mechanism. Quickly, session defenses, most of this is built into your framework. So I think the things in red are what you need to deal with as a developer. First, to support absolute timeout. Very few frameworks, except for .NET, support absolute timeout. That means even if a user has been highly active for several hours and they haven't triggered idle timeout, and this happens more often as we get AJAX, because very often the web page will just hold the server every couple seconds for different client-side advanced features, and then idle timeout goes away. In the situation where you have that web app that's constantly holding the server, so absolute timeout becomes more important. One line of code is all you need to support absolute timeout in, say, a Java filter. If the current time is greater than the login time plus the absolute timeout value length, with every request coming in, you do this check, finish still the session. It's very easy to implement this on your own. Session fixation, easy enough. Every time a user logs into your system, invalidate the old session right away and regenerate a new session. No framework that I know of supports this. So clickjacking, we know about it. Click that one page, boom, I just clicked all your email. Click that start date, boom, I just deleted all your email. We know about this risk. The way to stop clickjacking is through X-frame option headers. We could say X-frame option deny, and then evil sites can no longer frame our site. Like if you try to load your inbox of Gmail in an iframe today, in a browser that supports X-frame options, it's just not going to work anymore. They do not want anyone else to frame them for the purpose of clickjacking. So these control, if you do not want other sites to frame you to stop clickjacking, then this is the best option for about 90% of browsers in use today. And if you want to support legacy browsers, we have a manual JavaScript mechanism. The Stanford guys, the Stanford researchers on clickjacking have broken every manual frame-breaking tech I've seen except for this. And this is still a fairly robust mechanism even for legacy browsers. I'm going to move ahead and then just go Google Code Magi clickjacking. You'll see an article describing this manual defense. This all goes in the head of your HTML, not in the body. It's between two head tags, so it loads before the body even loads. We should be using a lot of TLS, and I would love to rant and rave about the failures of the CA system. I won't do it in public, so we'll do that later. Moving on. Ryan, this is for you, baby. Are you ready? Are you ready? Who's this? Anyone know who this individual is? It's Dr. Strangelove, right?
He just saw us.
Is that correct? How I learned to stop worrying and love the WAF. I'm publicly admitting that WAF technology really has a place in application security. I hear a lot of purists saying, WAFs are for wimps. I will never use a WAF. Got to fix the code. WAFs suck. Most of those people have never dealt with operational defense of a website. If you're an administrator and your job is to protect a website, you know what you're using? You're probably using a WAF of some kind. So I'm going to call this virtual patching. There are a lot of different ways to be able to virtually patch your application other than code fixes for the sake of security. These next few slides are all from Ryan Barnett, who's here, and I took him and mixed him up a little bit, but I'm going to thank Ryan for... Mr. Barnett's been trying to encourage me to support the WAF for about 6 years now, and I surrender. I surrender to you, Ryan. It really does have a good place in application security. So why do we care about WAFs, web application firewalls, or other virtual patching technology? And I used to think these were BS reasons, but the reality is everyone who has a big company faces this. Let me repeat that. Everybody who works in a large company is facing this problem today. I don't have the source code anymore. We lost the code. Seen that more than once. No access to developers. They've moved to the next project. High cost, time to fix. It's going to take me a few weeks to push out this patch, or longer. For the larger the project, the bigger the problem. Benefit, I can efficiently, with this technology, reduce the attack surface or reduce the risk of an individual feature. And so I still like to fix the code. So for strategic remediation is fixing the code. That ownership is in the builder community. That's a developer who's in charge of that. And they focus on the root causes of the problem and creation of controls in the source code itself. That's definitely my preference. But that's idealistic when you're running 1,000 applications that have vulnerabilities in them. And so the ideas of strategic remediation pop up during design and initial coding phases of the SDLC is the best time to be dealing with what controls belong in your web application. But to get this right, it takes serious time, expertise, and planning. Defensive coding is brutally complex. Most developers to this day are still struggling with some of even the basic techniques around secure coding. And so tactical remediation is owned by the Defender community. These are administrators and operational staff whose responsibility is to defend a website when developers are off, doing their other project, and the site is now vulnerable to major hacks. So these are sites that are already in production. They're exposed to attacks. We may not be a DevOps shop. We may be a traditional shop, which is still pretty common in big organizations. And so we have WAFs like mod security, and the aim is to minimize the exposure window of vulnerability. I still think you should fix the code, but virtual patching will buy you time in many cases where you can patch it right away and hopefully fix the code if time and operations allow. So we have the OWASP Mod Security Core rule set that's run by Ryan. This is a open source WAF that I think is actually very effective. I'm done. Do I have time for a quick question, or no? I have no time for questions. As we say in Hawaii, real quick, this is how tourists do it, right? And this is how local Hawaiians do it. Like, ready? So hey, shaka, thank you for showing up. Have a great day, everyone. Thanks for showing up.